Good Tuesday to you again, everyone in gov/com631. Welcome again to week 12 and the review of week 11. Second video for this week, okay? Second cup of chai tea as well. Things in pairs go well together or something, I don't know. Okay. For this video, we're going to take a look at the work that you did last week. We're going to read your answers to the questions and fill in a little bit by way of discussion. Okay, I gave you, and I apologize in advance for the blizzard of ads that you had to endure while using the free online t-test calculator. Free only if you want to stare at, ads for Oscar Mayer sandwich meat or whatever it was streaming that's aimed at you. Okay, but it was there. It's simple. It's straightforward. Okay, so let's start with what we were doing. Remember, because this is good for you as a researcher to understand one of the standard tests within quantitative research in the empirical process, what a t-test is. Okay, a t-test simply compares the difference in the mean between two outcomes and asks the question whether that difference is statistically significant. Because when you have a sample, I'm getting my pad here. When you have a sample that you take, the differences in the average could be due to what's in your sample, and your sample is not representative of the population as a whole. So the t-test, which is it's actually a very simple little mathematical formula, and we haven't gone into that math here in this class, but a t-test asks the question, starting with the mean, the average, and then you move out from the average on the bell curve. So here's a perfect bell curve, which you don't always get. In fact, you rarely get a perfect bell curve when you're looking at how data comes out, but let's just pretend. Okay, here's the bell curve right in the middle here. This is called the central tendency. Right straight up the middle. Let's just make this a dotted line, like this. Right straight up the middle. That's the mean. Okay, and then as we go from the mean either to the left or the right, we get out towards the ends where the curve comes down towards the line, the tails. A t-test tests, okay, is there a statistically significant difference between where that mean is and how it comes out on either side of the curve? And is that variation due to something, the data in the sample, or is it statistically significant across the population? Now, what a t-test does not do is tell you why there's a statistically significant difference. T-test does not tell you that the one thing causes the other when you're looking at the two things you're examining. And remember from the description last week, a t-test is, and there are different kinds of t-tests, but three really major categories. But a t-test does not tell you anything about a causal relationship. Okay, so it's used when you have a single population doing two different things. So let's say everybody either smoking or not smoking, smoking or not smoking. Okay, or you have two different populations doing the same thing, like male and female runners. And I think I typed 100 yards. I meant 100 meters. Okay, I know a yard is not exactly a meter. All right, but anyway, you get the point. Okay, t-tests are good to measure if there's a difference in the outcome, a statistically significant difference. So remember that when you're reading through research one day, or you're taking a final exam somewhere, or wherever it might pop up. Okay, winky. Okay, so that's what we're about, and that's where you're using a t-test for. Okay, so I gave you a data sheet. Okay, And on that data sheet, I gave you the scores of the top 20 male collegiate athletes and the top 20 female collegiate athletes in the 100-meter run, 100 track and field. From track and field. Okay, and I asked you to run them through a very simple t-test calculator to see if there was any statistically significant difference in the average outcome. Okay, because you could have on the one side, like really slow guys and really fast women, and that might, have affected it. All right, and then I asked you to report on your findings through a series of questions. So let's take a look at those now. Question number 1, from the results on your t-test, what is the p-value? Given the p-value is the null hypothesis, and it really should be H0. Okay, apologies, slightly incorrect labeling on my part. Null hypothesis are always labeled H0. The null hypothesis is there's no statistically significant difference in the means, the average time a top college male athlete can run 100 yards. Yeah, I know it's 100 meters. Versus the means, the average time a top female college athlete can run 100 yards meters. Okay, is that accepted or rejected? Now, what makes a null hypothesis is it doesn't make a prediction. It says we can't tell, does this affect this, or we don't know. Is there any difference at all? Okay, who could tell? As opposed to the standard element within a hypothesis is this causes this. Comorbidities increases severe outcome. That would be the hypothesis that you would test in looking at the COVID data and doing the regression analysis. Okay, so there be the null hypothesis. So the question is, looking at the p-value, is it to be accepted or rejected? Amber, you're at the top here. Let's take you. The result of the t-test shows that the p-value is 0.0001, which means it barely even registers. Okay, because remember, we're dealing with decimal, expressions of percentage and decimals, and to turn that back into a percentage, you move the decimal point over to the right 2 points. So if you moved it over to the right 2 points, that would be 0.001. So less than 1% of 1/10, which is nothing. Okay, it's like doesn't even register. The p-value is 0.0001. Okay, with the result at, and I'm not sure what you meant here, Amber, with the result at less than 5%. So remember too, when you're running, whether it's t-test or regression analysis, one of the things that you have to decide on the front end is your confidence interval. Okay, now the standard confidence interval for just stuff happening out in the world is 95%. And you know what that means, right? That we expect that 95% of the time it's going to come out the way that we predict. Like the coin flip, it will come out between heads and tails because order has been ordered. The material world has been ordered by an orderer, God. But there's a 5% chance that there'll be, just whether it's a random occurrence or small micro factors, maybe a poof in the air as the coin is going up and down, that will change that absolute predicted outcome between 50-50 heads and tails. All right, 95% of the time that's going to happen. So if the p-value, and p stands for probability, is less than 5%, that means that that the confidence interval, it happened 95% of the time or more. And in this case, with the p-value being point and then 0.0001, the statistically significant difference in the means comes down, the confidence interval is now, like you could say with confidence, 99.999999% of the time, there is a significant difference in the outcome of the average speed of a top male college athlete and a top female college athlete, which means there's absolutely a difference. Okay, so make sure that I think that's what you're getting at, Amber, but make sure that you understand that 0.5% is representative of the confidence interval that you set at 95%. Now, there are different confidence intervals set for different kinds of research. In pharmaceutical research, the very low end for confidence interval is 98%, or it might even be higher. It might be 99%. Because if you turn a drug loose on the public that makes everybody grow a third nipple or something, you've got a big problem. It's called the lawyers are coming to get you. So the confidence interval has to be a lot higher. So it's not always 95%, but in the social sciences and where human behavior is concerned, it's 95%. Okay, so given how low the p-value is, there's significant evidence to reject the null hypothesis. Okay, yes, absolute evidence. 100. You can't be more positive than that. Okay, by rejecting the null hypothesis, I'm still reading from Amber here. Statistical data shows that the difference between men and women's average time is not due to chance. Basically, we can look to biology and physiology to find the difference between men and women's time. Okay, important point. Good point, Amber. Because the t-test doesn't tell you why there's a difference. It's just going to tell you there's a statistically significant difference. And here is where, and that's what, I don't know if you read the article, I included the link. I didn't require that you read it. But here is where those who have either a very low understanding of how statistics work, which, remember back to your reading, why should you be interested in statistics? Because it's the story of us, how we behave in relationship to one another. They have a very low understanding or no understanding about the mathematics of how behavior can be tracked, or they just don't like the outcome. I can't get inside their head. So if you read this little essay that I attached by a certain Kara Okobock, Ocobock, it's entitled "Sex in Sports: Men and Women don't always have the advantage." Okay, research shows that real difference exists in athletic capacities on average between men and women, but they cut both ways. Well, yes and no. Okay, and she goes on and she talks a little bit about physiology and anatomy, which is one of my undergraduate degrees. I was one of those psycho people that double majored and double minored. Okay. And so whenever I see stuff like this, I always start going, Okay. And in her work, or in this little piece here, so that said, there's some real uncontroversial averages between the groups typically categorized as women and men. So note the language. This is someone who I suspect just does not understand the significance of how data works. Okay, and she writes in the third paragraph, one only needs scroll social media comment sections to find claims that this was not a case of sexism. Okay, we're talking about someone who was a man competing amongst women. Okay. And so here we go. She says, a quick aside, different ways to find biological sex based on the presence of gonads, internal and external genitalia, chromosomes, and none of these consistently present a clear and hard boundary between male and female. Yes, they do. I mean, this is not a political position. This is an outcome of empirical observation. Now, if you watch the first video for this week, we talk about variables, whether continuous or categorical. And there are some things which are absolutely better described as categorical variables. Now, you can monkey around with the description all you like. All right. But the describing of the thing doesn't change the nature of the thing. So there are some categories that are binary, and gender or biological sex is one of them. So it doesn't matter how you define it. If you watch the first video, it doesn't matter if you think the swimming pool is full of water. If the swimming pool is not full of water and you jump into it expecting to get a nice cool dip, and what you get instead is a very sharp smack into the concrete, your imagining isn't going to change the nature of the smack into the concrete. Okay. So, when you read stuff like this, you go, yeah, okay. I don't know if this person is real clear on the empirical process. Okay, well, she goes on in the article and to say research indicates that women are better able to manage glucose, simple sugar used by the body for energy, stored in muscles where it can be quickly used and taking part in endurance events. Women also have more, I think she may have spelled this wrong, but adipositine, adipocin. Yeah, okay, so this is a typo. A hormone that regulates fat metabolism, a higher concentration of fatty acids, intermuscular triglycerides. These factors can all enhance glucose use. Glucose use using fat burning capacities during endurance exercise may delay the phenomenon of hitting the wall, point which athletes feel they cannot go further. Okay, that's true. See, one of the interesting things I find about this article, and we're going to get back to the questions, but one of the things I find interesting about this article is it begins with this section, at least, begins with a quick aside that there are different ways to define biological sex, and you can't use these characteristics, gonads, internal, external genitalia, chromosomes, hormones, as consistent means by which to define the sex. And yet, that we get down here to physiological characteristics. He said, no, that women manage this better, and it's true. They manage glucose for use better and hit the wall less. And then in the next paragraph, she points out anatomically, women tend to have a greater proportion of slow twitch muscle fiber. These are less powerful but more fatigue resistant, which lends itself to not hitting the wall as soon as men, which is also true, which is a what physiological characteristic, what makes women different from men. So now I'm not pushing political buttons here. This is an exercise in the empirical process. All right. Whenever you come across an article, take careful note of the author's position on things. First of all, if it defies reality, and then because empirical process is about observed reality and not what you would like to do or the way you would like to have things. Okay. And then secondly, within that observation of reality, that if there's a contradiction in how the author is presenting, in this case, her position, and there is, all right, we'll come back to the ideas in this article here in a second as we go through the questions. Okay, question number 2. I ask you, so we have this, I ask you to take a look at the p-value. What does the p-value represent, and what does it mean that a test result is significant if p is less than 5%? Okay, I'm going to take a duel, two of you here, Charles and Lane. Okay, Lane, you write, according to Rumsey, p-value is the probability associated with your test statistic. It measures the chance of getting the results at least as strong as yours if the claim that the null hypothesis were true. In the case of testing the population, means the further out your test statistics is on the tail of the standard norm, that is the z distribution, the smaller your p-value will be, et cetera, et cetera. Okay, that's true. But remember, one of the things that I want you to do, and if Elaine, this makes sense to you, just as is, perfecto. But one of the things I want to make sure that you do, everybody, Elaine, you too, is this makes sense in your head. So be sure you can put it into plain English in case you're asked to do so. So let me take a look at your answer, Charles. The p-value represents the probability that the means are different due to random chance. If the probability that if the probability that the means differ is greater than 5%, okay, so, or a p-value of 0.05, because remember, if you move that decimal place to the right 2 places, you'd go 0 and then the 5%. Okay, if it's greater than 5%, the difference in value from the sample is not considered important enough to be mathematically significant. In other words, the samples are not consistent enough to represent greater populations, so the comparison of the means could be an error. All right, so that's that confidence interval. So if what's happening is happening at 95% or below, then something is going on. Something is influencing the outcome. If it's 95% or above, then the outcome is due to the natural factors that are constructed into the material universe by the creator, like the flipping of the coin. Right now, when you have p-values, and it's not like an on-off switch, they're treated, when they're red, they're treated more like a dial. Because you can have a p-value that's right on the line, that's at 5% or 5.3 or even 6%. And there are researchers that go, yeah, there's some significance going on here. It's not very strong, but it is there. Or in the case of this exercise, you can have p-values that are so low, a point and then 4 zeros and a number 1, that there's absolutely no way that that this is, what's going on is due to how things are constructed. There's absolutely no way otherwise. Okay. So be able to understand in your mind, and however you watch another video, or maybe you call me during my office hour, we'll talk about it, to understand things like confidence interval, p-values, these sort of standard terms and reports in quantitative analysis. Okay, let's take a look at question number 3. Report the mean. That is, this is the average, and it was labeled M1 on the result page for your online calculator. For the 20 male runners, how does this compare to the mean for the 20 female runners? And that was, I didn't say it was going to be M2. I figured you'd figure that out. What does this comparison suggest about the difference in performance outcomes? We're going to come back to that phrase in this article for male and female athletes. Okay, Robin, let's take a look at you. M1, that is, this was the mean for the first group. And by the way, you could put the females in the first group and the males in the second group. It doesn't matter, just as long as you as a researcher keep straight who's in what, you've assigned to what group. Okay, so M1, which is the male, is the average time is 10.01 seconds for 100 meters. Man, that's fast, man. While M2 is 11.04. That's still fast for the women. This suggests that the mean, or the average time for the women runners M2, is longer than the mean M1 for the men. The difference in this mean suggests that it takes women longer on average to run 100 yards or 100 meters. Okay. All right. Now, here's another mistake. And in most cases, I do honestly think it's a mistake. Now, there may be some folks who are up to, shenanigans, and they do this on purpose. All right. But in many instances, I think this is just a mistake. If you go back to the article, the author of the article, what was her name? Kara. Okay. Okobak. Okay. She goes through these physiological differences between men and women, and which there's absolutely no question that there are physiological differences between men and women, and they create different interests for men and women. Okay, but what she doesn't address is what's being discussed here: performance outcome. Performance outcome. So remember back to the article. Why did Van Gogh cut off his ear? Well, you cannot reduce it to a single characteristic. It is a combination of things. So yes, as this article points out, okay, there's a difference in how men and women manage glucose. And yes, there's a difference in the proportion of slow twitch as opposed to fast twitch muscle fibers. Absolutely. Okay. But since you can't see what we're not asking a question about, and this, you might be saying, well, why is this discussion in a political sci class? Because this helps us translate the information into public policy. You cannot take, say, these singular differences between, say, glucose metabolism and density of high twitch fibers and pull them out of the context of the human body. Because what we're not discussing here is whether there's a difference between metabolism of glucose and density of certain muscle fibers. What we're discussing here is if there is a performance outcome difference with all of these factors combined. Difference between men and women in overall muscle density, difference between men and women in bone structure, difference between men and women in respiratory capacity and vascular capacity. There are big differences. And as a result, the outcome is significant. Now, there's something important here, too, about this question of sports. Okay. And it doesn't concern statistics. But, you can't and you ought not to look at statistics just in a vacuum and go, oh, wow, look at the numbers. Okay. Because there's a performance difference, an outcome performance difference between male and female. That doesn't mean that women's sports is not worth the watching. All right. It doesn't mean that women's sports ought not to be funded like male sports. That's what Title IX was designed originally for collegiate athletes. It just means that the performance outcomes are different. Okay. I mean, even within sports that are in terms of what the public prefers to watch, that are traditionally female dominated, like gymnastics, the outcome differences are stark, right? They're big. But people watch the sport, or ice skating, figure skating is another one. People watch the sport because there's a difference in the outcome between male and female, and there's a preference for the type of the outcome characterized by female performers, say in ice skating or gymnastics, as opposed to male performers in those two sports. So it doesn't mean we say, well, there's a difference in outcome. And this is, if you find somebody running down this track, they're not getting the point of the statistics. It doesn't mean that there ought to be a preference. When you're talking about something whose purpose is, for you to watch. Now, in other areas, yes, that it's appropriate to have policy that leans on outcome. Battlefield performance in the armed forces is an area in which it's quite clear that based on performance outcome, it's better to have men than women in a battle, actually humping the load because of outcome performance. But that doesn't mean that women who enroll in the armed forces are therefore disadvantaged because of that outcome. Those are two different things. Okay, so we need to I think part of the controversy around sports, and we'll go back to this article, bubbles up from this idea that if there's a performance outcome, there's a performance difference, then this makes one the lesser than the other. No, but what we can say from looking at the statistics is that there is a market performance outcome. All right, and as such, it's appropriate to give specific space for female athletes to compete and specific space for male athletes to compete. And it's not appropriate to allow male athletes to compete in a female athletic space because of performance outcomes. All right. And that becomes an unfair advantage for the biological male athlete. All right. Question number 4. And I have a confession to make. And I'll tell it to you after I read this question. Go to the website listing the 100-meter time. See, by question 4, I figured out that I said yards for the male and female and D1, Division I college athletes. And there's the link. Report the time for the 100 fastest male listed, a certain Ian Dosman from Cal State Fullerton. Now compare that time to the number 1 woman runner, the 100-meter listed on the site, a certain Sears from Tennessee. What does the comparison suggest about the difference between the performance outcomes of male and female athletes? Is the difference statistically significant? Why or why not? Okay. Here's my confession. This was a trick question. I was trying to trick you. All right, Lane, because you and I had a discussion about this on the phone. I'm going to go to you. And you say, you cite the question again. The answer is in 2004, Division I 100-meter fastest male time is or the 100th, the slowest of the 100, is a time of 10.34 seconds. Division 1 female fastest is 10.77 seconds. So the slowest out of 100 men is still faster than the fastest out of 100 women. Okay, but the question is that statistically significant? Okay, so this is what you answered, Lane. The data suggests that the top 100 men of the 2024 outdoor track Division 1 meters are faster than the number 1 female. The researcher would need to garner more data, i.e. a t-test along with significant levels, to make further statistical claims. Exactly. In other words, the answer to that question is no. It's not statistically significant. If you take one instance of a thing, doesn't matter what the number is. It doesn't matter if the bottom 100, the guy in the bottom 100 is faster than the top one from male to female. Doesn't matter. If you take one data point and you compare it only to one other, that's not statistically significant. So when you find people that say, well, and this is part of the article that I gave you, there are some people who are born intersex, which is absolutely true. This does not mean that this is statistically significant and that men can be women and women can be men. That's like saying if someone was born with one arm instead of two, which does happen, then people could have any number of arms and we just can't tell. We can't say that people have two arms. Now, that doesn't mean that if someone's born with one arm as opposed to two, they're less of a person. Okay, it just means that you can't take these minimal data points, whether it's one or just a few or very small percentage of the total population, and extrapolate from that something that's significant. That's just not good empiricism, and it's bad logic, that goes hand in hand with the lack of the empirical method. Don't understand the process. I don't mean you, present company excluded. Anyone that's doing that doesn't understand the process. They don't understand how the math works in the statistics, and they don't understand what empirical observation is. And then you make mistakes. So, all right. So, full confession. I feel much better now. Trick question. So if you answered anything other than, no, this is not statistically significant, you got it wrong. Okay, everybody. Have a great week. All right. That's 2 videos of 30 minutes each, 60 minutes of me. Yeah, I think that's probably pushing about the limit of what someone can stand. All right. Take a look at which one of these you look at first. Make sure you look at the other video because I'll tell you what's coming up or what we're doing this week. And, week 12, we're cruising right along. So I'll see you on Canvas. Have a great, great rest of the week. Oh, and remember to vote. God bless. Bye-bye.